So today we're going to be making an assemble tool using geometry nodes, which is obviously inspired by IronMan 3, and you can use it on any object that is made out of different pieces, like a fractured statue or a robot like IronMan. Since some of you have a very short attention span, let's do a quick rundown of what we're going to be doing so that you have something to go with before you leave. We're going to start by fracturing an object. This is not necessary if you're using a robot with different pieces, and then turn those pieces or fractures into points that we later turn into vertices that we extrude using an extrude node. We're going to use the raycast node to detect the ground below our points, add more resolution to our extruded vertices by turning them into curves and resampling the curve to get more points, push these points onto the closest surface of our ground. Now if you compare the starting points of these curves, they no longer line up with the original positions of the instances they were extruded from. Now we're going to create a falloff so that the closest points to our pieces are not pushed to the ground. Now if you trace these curves, you can see they always go back to the original positions. Obviously, the version we end up making in the tutorial is going to be more complicated than this, with more forces and more velocities. So if you want to watch that, continue. If you want to download this tool, you can get it on my Gumroad page, Patreon, and my YouTube membership page. So for this setup, you need two things. You need the fractured pieces of any object. It could be a house, it could be a character, it could even be a robot like IronMan with different pieces. You can assemble them back with this tool. The pieces have to be in a collection, and we can hide that collection for now. And let's add a plane. Go to geometry nodes. The first thing we're going to do is import in our collection. Make sure that is set to separate children. We're going to first turn these into points, so instances to points. We want to convert these to vertices, points to vertices, extrude these. We need to extrude the vertices. Just like that. You can even randomize the offset using a random offset, just like that. We can bring our ground, make sure it's set to relative, use raycast node. This is going to be our target, and the only thing we need this for is to get the hit position. So with this raycast, we're just shooting rays down until they hit the ground, which is this ground here. So when a point is here and shoots a ray down here, it will just use the position of that hit point as its new position. So all you have to do is use a set position. We need our original points, just like this, and the hit point to be used as the position. I can use a vector mix and bring in my original position. Originally they were here, and if we use the raycast, they are snapped to the original position. And let me bring back my ground here. We don't have any points here, so what we're going to do is first convert this to a curve so that we get more points. So just like this, and resample the curve to get more points, and that will give us something like this. Now if we look at the execution time for these geometry nodes, you can see that this raycast seems to be quite heavy, and you can even see it when I'm trying to change the values here. It's a bit slow. So what I'm going to do, instead of using a geometry like this that has a lot of vertices, what I'm going to do is just create a plane like this, give it a subdivision surface. Make sure this is set to simple. I can even look at the subdivisions. Turn off optimized. I can subdivide this by maybe 7, just like this, and use a shrink wrap that is projecting for this ground, and I can use a project surface. Then just now you can see this is projected directly onto the ground, and this is going to cost us less than using a dense mesh like this. So let's go back to our setup. I'm going to call this GN, but I can easily find it. Now we're going to switch this out for this. Now you can see the computation time has dropped significantly from 193 microseconds to about 5 microseconds, which is much faster. And the other thing we could do is, since we can easily scale this up and it won't affect our nodes, we can even just duplicate this, Shift D, and move it maybe different copies here. The shrink wrap node has an auxiliary target, so I can use that, a different object as an auxiliary target, and that will be also added into the shrink wrap. For this here, I can just add another shrink wrap and just use this. But again, you need to use project. And yeah, so, and I can hide this for now. If I scale this, you can see that I'm still using my raycast is working very well. And I can expand these lines. I can push them out even further. And you can see that, yeah, they're using this as our target, our new target. So you can see how these are wrapped over the surface. Now, one thing you will notice, if we bring back our original points, so I can use a join geometry to join this with the original geometry. And let me just scale instances. Yeah, just scale them down. Let me hide my grounds. Yeah, if I look at this, you can see that before we added in our raycast, let me just bring this back. You can see that the starting point of these curves was the instance position. If I scale this down even further, you can see that each instance, each curve was extruded from the instance. But when we add our raycasts, you can see now they're no longer starting from that position. So what we can do now is using this mix node, you can see I can change from the original position to the raycast position, and I can create a gradient or a mask so that the nearest curve points to the pieces are not affected by the raycast, so that we have that gradient. So all the points that are far away from the instances are affected, and we can do that quite simply by using this spline parameter, since these are curves. Remember, spline parameters have a length, so, and a factor that starts from 0 to 1. So here we have 0 and here we have 1. So we can use that as our gradient, and we can even try visualizing this, and you can see that there. So if we grab this and plug this into the factor, you can see we get exactly what we want, except we're getting the inverse of this. So I'll use a float. We'll use a float curve and a map range to flip these around. So you can see the points are now start from the instance, and then the raycast takes over. Except now I can just adjust how much of this is affected by just playing with these curves. Or I can even just just play with the maximum distance here, so I can adjust this. All our curves start from the points and then push out, just like that. Let's bring back our ground. I'm just going to make this a bit darker so that it's much easier to see. So now we can make these points move along their curves, their individual curves, by using a sample curve, and the curves we want to sample are these curves here. These are now going to give us the path our instances are going to move on. So we can use a set position, and now if I use the position from the sampled curves, if you play with the factor, let me bring back my curves using a join geometry to see the path these curves are taking. So play with the factor, you can see that the points are following a curve, and all of them are all here following one single curve. If you want them to follow multiple curves, you just have to use the index of all the curves, and now each of these is following a specific curve. I will remove the instance scale, and you can see now, if I play with the factor, you can see that now each point is moving. Now we have an issue where some of these go back and forth, like this here is going that side and then coming back. To fix that, just use the isHit, plug this isHit into the selection, and that way if a point doesn't have a hit position, it's just ignored. So now if I play with this, you can see that they all can collapse and follow different directions. But I don't want all of them to all move at the same point. So you can use a random value to randomize this factor. So now some can start at a different position than others, and we can even add a math node that way we can animate these randomly. So it's just like that. So they start off from different positions, Some of the starting positions are very short, so I'm going to come here at the, push this and make sure the minimum is also quite far for these. So you can easily animate this using a time node. So we need this to be reversed. I'm actually just going to use the frames and use a map range. We want the animation to start at frame 10 and end at frame 100. And we need this to be reversed. So you can see now we get a random movement. We can first remove the random value and just stick with this map range. So we want to start from 1 to 50 frames. And now you can see we have the points going in just like that. We want to introduce some randomness. We can come here before the frames and just use a math node to add some offsets, but this can be random. So let's say we add 1 to 0, and let's say 1 to 20. Yeah, so you can see some coming a bit late, and we can even just use a negative value to have, let's say, negative 20. So some start a bit late than others. So you can see this starts a bit late. Yeah, it's just introducing some randomness like that. But this looks too basic compared to what we had before, where particles have a bit of random rotation and they also orbit the object before they go into it, just like that. So let's work on that. So for the random rotation, we have, so these are instances. So what we can do is use a rotate instances, and we can randomize this value using a random value. Has to be a vector connected in here. This will just give these a random rotation. So if we play back, the problem is the final rotation will also be messed up. So what we can do is if we don't have this rotation, or if this rotation is set to 0, 0, you can see that we have the exact rotation we need. So what we can do is use a vector math with the operation of scale, plug this into the vector, and when this is set to 0, we have the right rotation. If it's 1, we get the random rotation. Remember, we have this map range that's basically giving us the same thing. So if I can plug this, if I plug this in here, we get random rotation as we want. So that's the rotation done. Now we want to make this more interesting by adding some forces that make these move around just like that. So to do that, we need to look at our curves. If we use a set position and use their original position and I use a vector math, set this to a cross product with a vector pointing up, this usually gives you that rotation. So if we plug this into the offset, you see, we don't really get much. If I increase this value, you can see that we are getting a slight rotation as this value increases. What we can do is use a combine XY to separate the vector here, plug it in here, and use another vector math here. But this time change this to scale so that we can scale this up and scale it down. But since these are curves that have a value from 0 to 1, just like that, we can influence this scale so that it's affecting the vertices close here less than the vertices close here. And since this is creating a rotation like this, it will also end up creating that rotation we want. So we already have that from this here. So I can just, actually, let me just grab this. So we have this spline factor. If we plug this in here, we get what we want. So just like that. If you want to make it more powerful, you can use a math node. If you add, it just rotates it like that. If you multiply, kind of changes the direction. But if you use power, you can make it more pronounced. We can bring our sample curve and use the modified curves. And actually I need to make some room, push these ahead. Yeah, so now I can use the new curves. These get that rotation, the rocks get that rotation, which I think makes things look more interesting. One issue you see that we have, actually I can disable these curves and you don't have to see them. One thing you will notice is that we don't have enough points to make this look super interesting. So we don't have enough pieces, so you can fracture this more, or what you can do is just come here into your original collection and just duplicate these pieces a few times. So I'm going to use this. If you duplicate these points by just joining them back using a join geometry into the collection, we should now double the number of pieces we have, and that will also double the number of curves we have. The problem is that these are still in the same position that they were. So if we look at them just like that, what we can do is we can use a set position, use a noise to alter their position. Just a bit. Let me use a vector math with a scale to make the noise, and subtract the noise offset that comes with the noise. So if we join these into the original pieces, you can see what we have, and I can even scale these down, scale using the scale instances to make them smaller. Now if we look at the updated version, you can see that we now have the updated version. So why is this? So, oh yeah, we need this to go in here. You can see that the small pieces also are added, and they also get their own curves. So if I bring back our curves, let me just add a switch node in case I want to see these. So if I bring the curves, you can see that even the small pieces have their own curves. We want more pieces, and you could duplicate this more, maybe join this, and that will give you more pieces. But we can do a better job than this. If you have the original mesh like this, let me just reset it and make sure it's aligned correctly. Instead of doing it this way, we can just bring back the original piece, which is this. Look at that, make sure I set to relative, and convert this to a volume, primitive mesh to volume, just like this, and you can see the volume, increase the density. Just what you can do with that volume is you can instance points in that volume, distribute points in volume. So this is our volume, instance in that volume, then instance on points, and the instances can be our collection. So I'll just plug this in here and make sure you use pick instance. And I'm actually just going to use a copy of this here and just plug it in here so that I can separate reset children so that the positions are reset. I'm also going to scale this down quite a bit. I look at this geometry and the collection. You can see some of these instances are popping through our mesh. So what you can do is grab the original mesh, which is this, and use it to check the proximity of these points here. If they're closer to the surface, and just delete them. So I'll use a delete node. I need some space here. Let me just push that up. Bring in our points and use this distance. So I can use a compare node. Compare. Change this to less than. So if they're close to the mesh, just remove them. And those are the points we want to instance our meshes on. So if we look at this, now you can see that without this, if I reduce this too much, you can see we start to see points on the surface. But if you want to keep them inside, we just have to reduce the points that are showing up. So all the points are now on the inside, just like that, which is exactly what we want. Now we just use this. We don't need any of this. So we just use the new points, these points, and these combined as the new pieces. So if we take a look at this, let me remove the curves. You can see we have smaller pieces and larger pieces, and they all merge to turn into the mesh. So that's how you add extra pieces to your mesh, extra points. So I think another thing we could do is just randomize the scale quite a bit, because they seem to have, the small pieces seem to have the same scale. Just make sure that they are not too large. I also want to try this out on IronMan. So this model is by VFX Boy. So I'm just going to download that, and yeah, so we have different pieces. I can go back to my geometry nodes, hide the IronMan collection, come to this, and we need to expose. Select this, go to geometry nodes, and just expose the collection. I'll just use our group input. I want to expose this collection, the collection. And this should also be the same collection we're using up here. Let's change this to the IronMan collection. Hide the IronMan collection. And just like that. There's a ton of stuff you can do. You can now have IronMan, the IronMan suit assembling. Anyway, that's it. If you want the project files, links are going to be in the description. You can get it on my Gumroad page, Patreon, and my YouTube membership page. See you in the next video.